Hi everyone, welcome to our first virtual lab. Okay, so it's lab number 2, which is density. Okay, now before I get into the nuts and bolts of the experiment itself, let's just remind ourselves real quick actually how you get to the experiment. Okay, so here's a little checklist. All right, okay, number 1, go to the lab site in Canvas. Okay, I think it's GPR 101. I think it's group 101. Okay, now you've probably already done that because you already did the safety video, right? Okay, actually no, you didn't. I gave you that video, didn't I? Okay, so if you look in the announcements, okay, if you look in the announcements, there's the first day of class announcement. I also sent by email. Okay, there's a link to this location. You go there, you sign up, and then it appears in Canvas as another course. Okay, so make sure you set up your kind of lab course in Canvas. There's a link in the announcements. If I remember, I'll do a screenshot. Okay, I'll do the people like YouTube do. It's over there or over there, it's hard to know, right? Okay, it's on the page somewhere. All right, so go to the GRP 101 link, take a look, and then when you're there, okay, go to modules, all right, and what you got to do is sign up for the Pivot Interactive Learning. Okay, now the Pivot site is different than the Canvas site. At the Canvas site you get your actual labs, okay, which I'll go through in a minute. So these physical labs, right? Okay, you can actually fill them out online, which is nice too, fileable, right, or fillable. All right, but bottom line is go to modules and you'll see these labs, but you've also got to sign up for the Pivot site itself, which is a different website, which is where you do the virtual experiments. Okay, and sign up for Pivot. Okay, now in that same email in the announcements, and hopefully I'll flash up the actual codes, right, you have some instructions to go to the Pivot site and sign in using a class ID. So I'm doing 3 sections of 101 this fall. Okay, so you're either in section 20, 21, or 310. Okay, and each one of those sections has a different ID code. Okay, so hopefully they're somewhere on the screen right now. Use that Pivot code to actually access the Pivot site where you'll actually do the labs virtually. Okay, all right, so let's just recap. You get your GPR 101 link sorted out. You'll then get a GRP 101 link, and then you'll have a new class pop up in your Canvas. That's your lab site. Okay, go there to download the experiment site, the copies, the lab copies of the experiment. Okay, however, in order to fill those out, you have to do an experiment virtually, which involves going to the Pivot site, and as I mentioned, there's a code listed at the announcements area where you can sign up for Pivot. Okay, so I'm gonna, going forward, assume you're okay with and you're signed up with Pivot. Let me know immediately if you can't sign in using that code. Chances are it's going to be okay, but just in case. All right, now the game plan is you download the experimental files from the group Canvas site. Okay, and for the density experiment you're faced with actually 2 experiments. Okay, one for a liquid, one for a solid, and they both have slightly different ways to work out the density of those things. So in each case you're given the list of possible unknown identities, right, and then you do essentially an experiment to figure out the density of that unknown. Okay, now in the fillable file you can fill in these gaps, right, which is nice. Yeah, that's nice. But when you save that file, make sure you save it as a regular doc or PDF. If you send it back to me as a fillable file or fileable file, I won't be able to open it even. Okay, so if you do decide to fill in the gaps using the fillable file, make sure you save it as a regular file to send to me for grading. And of course, as mentioned on the website, send to my personal email, right, from your personal email. Wow, it's my college email, right, pmails@jjc.edu, not from Canvas, because Canvas sometimes has a bug when sending attachments, and we don't want to have that problem. Okay, all right, now let's get into some nuts and bolts. So I'll just kind of talk out loud a little bit about the ways you solve these unknowns, right? Okay, so For a liquid, so for the liquid, okay, you're using the graphical method. All right, so if you noticed on the sheet there, if you got it in front of you, okay, you have a bunch of different samples, a bunch of different volumes, and a bunch of different masses. So essentially you're weighing the same material a bunch of different times. So you get a table of volume and mass data. And what you're going to do, you're going to plot a graph, right? Okay. So there's the volume in milliliters, there's the mass in grams, right? Now if you think about it, move that down. If you think about it, what's going to happen? Something with no mass has no volume, so the intersection will definitely be at 0, 0. If this was water, 1 milliliter would weigh 1 gram, right? 2 milliliters, 2 grams. So as things double in size, they double in weight. Now, how much they weigh per milliliter is their density, right? So, bottom line is this, you're going to get a linear plot, okay? So it's called the linear graph, right? Okay, fair enough. Now, you could, as you know, density is mass over volume. You could take any one of these plots, divide the mass number by the volume number, and get the density. So, you know, that's 1, 2, 3, 4, maybe 5 or 6 individual densities you could work out from a table, and then take the average and you get a pretty good value. But when you graph data, by putting a line through that data, it's like you're mathematically doing an average, okay? So if you think about it, density is mass over volume, which is rise over run. That's the gradient of a straight line. So for a straight line, y equals mx plus b, as you know, right? But what's y? Y is mass. Mass equals m, the gradient, right? Which is the density, times the volume plus b, all right? So m equals density times volume. We know that from our little triangle, right? Density is mass over volume. All right, mass is density times volume. Okay, so that's the slope. And the intercept is 0 because, you know, 0 mass is 0 volume. Okay, so you should get something like that, all right? So when you plot these data points for the liquid, you should get a pretty straight line. Okay, and what it asks you to do is plot a linear regression, and the computer will plot a line of best fit that's straight through those points, right? And it will pop up an equation like this, but it will give values for m and b, right? Okay, so whatever the slope is, that's the value of density. Okay, so that's how you read a mass versus volume graph to find density. It's just the slope of the straight line. Okay, also ask you about the correlation coefficient. For a perfectly straight line, the correlation coefficient is 1, right? Okay, so you should be getting, for a straight line, there's no such thing really as correlation coefficient as 1 unless it's fudged data. So you put, if it's real data, sort of 0.99, 0.98 is really good. Okay, so quote the R value, correlation coefficient, quote the slope, and probably the intercept, and that's how you solve for density using the relationship between mass and volume. All right, fair enough. Now, when you move on to the next data set, which is solids, okay? So for solids, you have a slightly different way of doing it, and I kind of talked about it in the notes a little bit when we worked out the density of the dice, right? So if you've got that far, and I really advise you, I should have maybe said this at the start, make sure you finish the density part of the packet, right? The third packet, before taking a look at this, this lab, okay? Now, bottom line is, and I can kind of draw it here, solids. So let's say we have, just like in the, you know, I could just basically just refer you to the video at this point, but I'll remind you, right? So if we have a regular object, right, the volume of a cube is length times width times height, right? So if I just bust out a ruler and measure, you know, it's 2.5 by 2.5 times 2.5. Now, it may or may not be a cube, but if it's a rectangle, sorry, like a brick shape, just measure all the sides, right? Assuming it's a pure cube, you may have a slightly more irregular shape, like a, you know, a brick, right? But then you can work out the volume in centimeters cubed, yeah? Okay, and then as you know, density is mass over volume. What the data set I think asks you to do, and I'll just confirm by looking, okay. Yeah, it pretty much asks you to do that same calculation. Okay, so if we look here, We've got the mass, so in a lab situation you just weigh, maybe it's a cube of aluminum or something, right? You measure the length, the width, and thickness or height, right? Okay, length times width times height is volume, so that's just what we did right there. Okay, but remember these numbers could be different if it's a brick shape, okay? And then hey, density is mass over volume, grams divided by centimeters cubed would be the unit. And then hey, once you've found the density, they give you a list of possible suspects, right? So you can tell me which one it is, okay? And back to the pivot site, they'll actually, I think kind of boringly, show you someone measuring something or show you something to measure, okay? So you can actually work out those dimensions. All right, so let's just recap. Let's go back to the checklist, right? So real quick, make sure you're signed up for the group Chemistry 101 lab site, okay? Check the announcements area. It was my first announcement of the semester. I think it was something like, things to do on day one or something like that, okay? So there's a link, okay? Go there, sign up, make sure it appears at your Canvas as a new class essentially, which would be called GRP 101. When you click on the Canvas GRP 101, it takes you to an area where all your copies of your labs are. This is what I'm looking at right here. You can download them. Some of the files are fillable, meaning you can actually fill them in, save them as a regular document, and then you don't have to kind of print and handwrite them, okay? So that's nice, right? Okay, remember if you do actually print the doc version or the PDF version, you can edit those without writing by hand as well, which is fine, right? So feel free to just word process away, right? As long as the gaps are filled in, okay? So go there, get those files. And also, if you look at the announcements, same announcement I mentioned up here, you've got to go to a separate site, the pivot site, where you actually do the experiment virtually, okay? So you're able to do virtual measurements and things, okay? So you'll fill out these sheets by doing that virtual experiment at the pivot site, and there's a special ID number for you to log into the various sections you're in. So make sure you know what section you're in, use the correct ID number from the announcements area, and you're in, okay? And then watch those pivots. And then, finally, as going to be with every lab this semester, once you've got that final lab, or in this case 2 labs done, right, save them as regular PDF or doc or docx files, email back to me at pmills.jjc.edu, my college address, right, from not Canvas, right? So maybe it's from some other account, maybe it's from your Google or something, right? It doesn't matter where it comes from, as long as it's not from Canvas, because Canvas can bug out with email attachments, which we learned to our displeasure last semester, okay? Hopefully that makes sense. Now, of course, this is going to appear both in modules and discussion. If you have any questions, and this is going to sound mean, right? It's not, right? Don't email me directly if you've got a question. Put the question at the discussion area for this lab, because then other students probably have that same question. I can answer it, and many people will benefit from that knowledge, not just one, okay? And also do that with the water cooler chat. So the water cooler chat, if you have a general question about the course and you put it up in water cooler chat, I will answer it, okay, but I'm going to give students a chance to answer it first, and anybody who answers a water cooler chat question gets a point of extra credit, okay? So I want you guys to kind of help each other through discussion, okay? So it's kind of hard enough not going to the classroom, but then when you're kind of in this environment when you don't see people, it's hard to kind of make that connection. So I want people to kind of really communicate as best as possible at the site, okay? And so I'll make it worth your while with a little bit of extra credit, okay? So extra credit for anything posted that's helpful, essentially, all right? So I want you guys to help each other, and you'll be rewarded for that. Okay, also don't forget, watch the deadlines, okay? I'm going to kind of post stuff on a weekly basis, and when you open Canvas, there's a little calendar, and it'll give you a list of things you have to do with the deadlines that particular week. So for week 1, there's obviously the first lab you had to do, and then like the first packet you had to do. In week 2, there's 2 packets and this experiment, okay? So, just keep it in kind of week-sized chunks, and I won't open the next week until that week arrives, okay? So if you notice this week, I'm actually talking to you on week 1, Wednesday afternoon, right? I'm probably not going to even open this until Saturday night or Sunday, right? Because that's essentially the start of the next week, okay? So look for that, all right? So look for weekly assignments posted sometime during the weekend before that week starts, okay? And you have until the whole week to finish those assignments, typically. All right, stop there, okay? I'll today's Wednesday, so it's kind of weird. You're not going to see this until next week, but I will see some of you on Teams hopefully tomorrow, which will be our first office hour. So hopefully I've seen you. Let's use this. It's kind of it's like watching a Star Trek episode when they're moving backwards and forwards in time. You never know which tense to use, right? So I'm talking to you from the future, from me now, and I'm going to see you tomorrow, right? Which is you are yesterday. Okay. All right, I'm a nerd. Okay. All right, so stop there. I'll talk to you guys next time.